Hello everyone, we are group 7 and in today's video we will be learning about DMA in computer architecture. I am Siddesh Dhumse, roll number 39. So DMA or direct memory access is a crucial component that enhances system performance by enabling efficient data transfer between peripheral devices and memory. Join us as we explore the in and outs of DMA. So what exactly is DMA? DMA, as we mentioned earlier, stands for Direct Memory Access. It's a feature in computer architecture that allows peripheral devices to transfer data directly to and from computer's memory without involving the CPU. This offloads data transfer tasks from the CPU, resulting in improved system performance. But how does DMA actually work? Come on, let us find out.
Hello everyone, I am Krutika, roll number 36. We will begin by discussing how DMA works. DMA controller acts as a mediator between peripheral devices and computer memory. Let us learn about this process in few steps. Step 1. Initialization. The CPU sets up the DMA controller by configuring its registers with the appropriate parameters such as the source and destination addresses, transfer size, and transfer mode. Step 2. Requesting DMA. When the peripheral device wants to transfer data, it sends a DMA request to the DMA controller specifying the source and destination addresses. Step 3. Bus arbitration. The DMA controller checks if the CPU is using the system bus. If the bus is free, the DMA controller gains control and begins the data transfer. Step 4. Data transfer. DMA controller directly accesses the system bus and transfer data between the peripheral device and memory. It reads data from the source addresses and writes it to the destination addresses or vice versa, depending on the transfer mode. Step 5. Interrupt generation. Once the data transfer is complete, the DMA controller sends an interrupt signal to the CPU, informing it that the transfer is done. Now, let us move to our next slide, which is components of DMA. The primary components involved in DMA are the DMA controller, peripheral devices, and system memory. Basically, peripheral devices provide or consume data, and system memory is the source or the destination of the data.
Hello, I'm Prajakta. So I'm here to explain you about advantages of DMA. DMA offers numerous advantages that significantly impact system performance, which are increased system performance, faster data transfer, efficient multitasking, reduced CPU overhead, lower latency, support for large data transfer. Firstly, it reduces CPU involvement in data transfers, allowing the CPU to focus on other critical tasks. This results in improved overall system performance and responsiveness. Secondly, DMA enables faster data transfer compared to traditional CPU-mediated transfers. By accessing memory directly, DMA eliminates the need for the CPU to handle every single data transfer, thereby reducing latency and enhancing data movement efficiency.
I am Prathamesh Dongde, roll number 40. I will be telling about disadvantages of direct memory access. While DMA offers numerous benefits, but it also has some disadvantages like complex implementation, requires careful synchronization, security risk, limited control by the CPU, increased system complexity, compatibility limitations, synchronization between DMA transfers and CPU, access to shared memory is essential to avoid conflicts and maintain data integrity. Another consideration is security. DMA transfers bypass certain security mechanisms implemented by the CPU, making it necessary to implement robust security measures to protect against unauthorized access and data breaches.
Hello, I am Shresh and I will be explaining modes of data transfer. So there are basically two modes of data transfer. First is burst mode and the second is cycle stealing mode. Now talking about the burst mode, DMA controller transfers a block of data in a single burst. Minimizing overhead. Burst mode is a mode of data transfer where multiple data transfer occurs consecutively without the intervention of the CPU. In burst mode, the DMA controller takes control of the data transfer process and performs a series of consecutive data transfer between the peripheral device and memory. By minimizing CPU involvement and maximizing data transfer efficiency, burst mode significantly improves overall system performance. Now talking about the second mode, that is the cycle stealing mode. DMA controller interleaves its transfer with CPU operation, temporarily pausing the CPU when necessary. In cycle mode, the DMA controller waits for specific CPU cycles such as memory access cycles when the CPU is not actively using the system bus. During these idle cycles, the DMA controller takes control of the system bus, access memory, and performs data transfer between the peripheral device and memory. Cycle mode is useful in scenarios when a tight coordination between the DMA transfer and CPU operation is required to ensure data integrity and system stability.
Myself Harsh, my roll number is 41 and I am going to explain you about applications of DMA in various domains. Some of its prominent applications are: first, disk I/O operations; second, network data transfers; third, graphic processing; fourth, audio or video streaming; fifth, high performance computing; sixth, DMA also plays a crucial role in network data transfers, allowing for efficient data movement between network adapters and memory. This enhances network throughput and performance, making it ideal for data-intensive applications like file transfer and video streaming. Additionally, DMA is utilized in audio and video streaming applications, where it ensures the continuous and uninterrupted transfer of data from storage to playback devices. This guarantees smooth playback and eliminates buffering delays.
So far, we have seen DMA is crucial aspect for computer architecture that enhances system performance by enabling efficient data transfer between peripheral devices and memory. By offloading data transfer tasks from the CPU, DMA improves overall system responsiveness and enables faster data movement. We also explored the workings of DMA, its advantages in terms of reduced CPU overhead and improved multitasking, and also its disadvantages. Thank you for joining us in this video. We hope you found this video informative and gained a deeper understanding of DMA significance. Make sure you hit the like button and let us know your thoughts in the comments.